Hi, I'm Natalie,
I'm Lynn.
I am Siwar.
and this project is the synthesis and analysis of sulforaphane at various temperatures. So, to introduce, sulforaphane is a chemical found in many different cruciferous vegetables such as broccoli, cauliflower, Brussels sprouts, and cabbage. And it is known to prevent cancer, heart disease, and inflammation, which is why we are interested in it. So, for our research questions, we are asking at what temperature do cruciferous vegetables have the highest sulforaphane content, mainly broccoli? And which vegetables have the highest sulforaphane content, broccoli, cabbage, or cauliflower? And we are hypothesizing that if the temperature of broccoli is increased, then the concentration of sulforaphane will decrease.
So for our objectives, we're trying to synthesize sulforaphane and we're determining what vegetable has the highest sulforaphane content out of broccoli, cabbage, or cauliflower. And we're trying to determine what temperature will yield the highest sulforaphane content in broccoli.
For our synthesis, we are performing a four-step synthesis in order to make sulforaphane. And we have currently gone through the first three steps and are currently characterizing that third step. And we have made our products from the second and first steps, which Siwar will show you the NMRs.
So here's the proton and carbon-13 NMR from the first step of our synthesis. We got a 59% yield and about 0.7 grams of 4-methylthiobutyl. Each colored circle is corresponding to its respective group.
For our quantitative study, we have bought a standard solution of sulforaphane and we're diluting it down with acetonitrile and making it at different concentrations. And then we're running it through HPLC. And for our parameters here in the middle, we have a C18 column and our pump is methanol. And then I'll hand it over to Siwar for our results.
Here's our calibration curve of our standard sulforaphane dilutions, showing the sulforaphane concentration versus peak area. And as you can see, there's a positive linear line.
For our kinetic study, we are using raw broccoli and then we are cooking it at different temperatures 20, 40, 60, 80, and 100 for 5 minutes. We're benching it in ice water for 30 seconds and then we soak that broccoli in methanol for 48 hours. We then water wrap that methanol off, which creates a crude extract. And we take the crude extract and extract it with chloroform and diluting it down in different concentrations with acetonitrile and running it through HPLC with the same parameters as our quantitative study. And I'll hand it over to Siwar for our results.
For our kinetic study, we still need to run our extracts against our calibration curve and plot a concentration versus temperature graph. However, here is a concentration versus temperature graph from the literature to give some idea on what our data may look like. The literature shows that the highest amount is found in treatments 5 and 6 with a temperature of 60 degrees Celsius. And as the temperature increased, the sulforaphane content decreased. To conclude, we only have one more step of our synthesis to complete. We got a R value of 0.9987 for our quant study. Then we made all of the extractions from our broccoli for the kinetic study. In the near future, we would like to finish up our synthesis. And for the quantitative study, we want to cook cabbage, cauliflower, and broccoli at different temperatures and quantify using HPLC. Then for our kinetic study, we would like to run our extracts against the calibration curve, then plot a concentration and temperature graph. I would like to thank the AG program and the chemistry and biochemistry department for funding our project.
Thank you.